today we're going to discuss integration leading to trigonometric functions. Okay, let us have some exercises. So exercises. Evaluate the given integral. Evaluate the given integral. Actually, it's not correct to say integrate, okay? Because there is already integral sign. When you integrate integral, it is anymore another operation. You're going to integrate the integral. So evaluate the given integral. But if you're going to have just the integrand together with the differential, then it's all right to have integrate. Let's say you have integrate sine x dx. Yan. Integrate, okay lang. Your instruction is that. But if you have already integral sign, evaluate or perform the indicated operation. No? Number one, integral of x to the fourth, then sine of x to the fifth minus pi. Okay, guys. Wait a minute. I am running out of ink. Dx. So what do you think is the possible u here? So of course, if you see trigonometric, try first its argument, no? Its angle, but remember, angle is measured in radian measure, huh? So let's try taking its angle as the u, no? And then verify if the du is present inside the integral sign. What's the du, guys? What's the du? Anyone?
5x raised to 4 po.
Okay, very good. Talagang paggaling kay Sir Bong, magaling kayo. Differential niya si Sir Bong, no? O yan. At ibig sabihin, you learned how to differentiate, no? So, we now have, let's write. So, because I think there is missing, no? Since there is missing 5, therefore this is not yet correct, no? So let's rewrite that so that it will take the form sine u du. So sine, our u is x to the fifth, yan, minus pi, quantity multiplied by x to the fourth, then dx. So again, we are going to what? To replace x to the fourth by what? So, ano daw ang loob nito? Sine u. So, this is u. But what is x to the fourth dx, guys? So, from here, what is du over 5, guys? That is equal to x to the fourth dx. So, what is x to the fourth dx, guys? Du over 5, right, guys?
Yes po.
And this is equal to 1/5 integral of sine u du. So this is now the formula. And what is the integral of this? The integral of sine u du is what? Negative cosine
u.
No? 10 times 1/5. Number du, no? Plus c. But what is our u, guys?
5 raised to 5 minus pi.
5 raised to 5 minus pi, no? Okay. Then plus c. Okay. Actually, this argument can be simplified. This cosine of this argument. Because pi is a pi minus something. That is a formula in trigo. But it's all right if you can't remember. So it's all right because once you expand that, you will come up with cosine x to the fifth, cosine pi, but cosine pi is negative 1. And then plus sine x to the fifth, sine pi, but sine pi is 0. So this is the same as what? Negative cosine of what? X to the fifth times negative, it will be positive na 1/5 cosine x to the fifth. Okay? Okay, number 2, we have integral of um, secant, let's say, squared theta, d theta, then over secant of, yeah, of tangent theta. So what if you have this, no? Oh, there are a lot of trigonometric functions, no? There are a lot of trigonometric functions. We have secant, we have tangent, yan, and another secant on top. But you have to see how they are related to each other. Okay, guys? What do you think is the first step to do? So, if I'm going to take secant squared, theta is its argument. What is the differential? D theta. So, what will happen in the denominator? So, you cannot just draw it or neglect it, okay? So, it means secant squared u du is not the correct formula to be used, no? So, instead, let's try to have the secant. Its argument is tangent, and tangent is related to secant squared. But we do not have 1 over secant. What we have, cosine. From trigo, I can write that cosine of what? That is 1 over secant, that is cosine. And then its argument is tangent. And the derivative of this is what? Secant squared theta d theta. Did you get that, children? So, what is this, guys? What is this? This is my u. And what about this, guys? Du. So, cosine u du. Cosine u du. What's the answer if the sound is integral of cosine u du? Guys? David Ludi? Alvin Merck? It is what? Integral of cosine u du. It is sine u, okay? But what is my u, guys? Tangent theta. Very good, no? That's it. Then plus c. Okay? And then number 3. Integral of cosecant squared of 4x ln of 4x plus 5 dx over 4x plus 5. Okay, guys? So, do we have in the list cosecant squared? Yes. So, let's try if it's u, if this is its u, if its du is present. Okay? So, let's see. So, let's rewrite this first into cosecant o squared of ln of 4x plus 5. Yan. Hoping that ln of 4x plus 5 is its u, no? U of cosecant squared. Then dx over 4x plus 5. Let's find out if this is its du. So what is our u? We take it ln of 4x plus 5. Okay? Yan. What is the du, guys? What's the du? 4 dx over 4x plus 5.
4x plus 5.
Okay, very good. So let's read integral of cosecant squared u but not du. So for this to be du, we need to supply 4 and balance outside by what? By 1/4, no? Let's have correction factor instead of substitution. Let's go directly. So our goal is to multiply by what? By 1/4 outside because we're going to multiply inside by 1 by 4, no? So cosecant squared of ln of 4x plus 5, then times, so I'm going to multiply by what, guys? By 4, no? So I will supply 4, but originally that 4 is not present. That's why I balance it outside, no? Remember, only constant can be moved and can be moved out and inside of the integral sign. So I can multiply here and then I can balance outside by 1/4 because that is a constant, that 4. But if the missing contains a variable, you cannot supply inside and then balance outside. Is that clear, children? What's now the answer? 1/4. Now, by the way, if you inserted something here, do not put equal, ha? Because if you put equal, it means it is referring to the last that you had. So, considering that this is what you mean, no? So you just put implication. So then here I can now write L equals, now it means from here. So integral cosecant squared u du, what's the answer? What's the answer, guys? Negative
Negative cotangent.
yeah, negative cotangent, and then copy the argument ln of 4x plus 5. Okay, and then of course multiply by 1/4 plus c. So let's have tangent, and then I have here 3 to the cotangent x, then multiplied by dx. So this is dx multiplied by 3 to the cotangent x dx all over let me make it bigger, all over sine squared x. Okay, what about that? What do you think our main function here? Now, if you have 3 to the cotangent x, it is related to 3 to the cotangent x, no? Because when you get the derivative of this, it has this part, okay? So it means our main function is tangent, no? So we write it in the form of what? In the form of integral of tangent u. But what is our u? 3 cotangent x. So let's try if that is really u, no? We will be verifying. So then we have 3 to the cotangent x dx over what? Over sine squared. Okay? Cotangent is related to what? The derivative is related to secant squared. But remember, cosecant squared I mean. But sine squared, when you bring it up, is cosecant squared. So it means possible that this is d, you know? All we have to do is to check well if that is really part of the du. Okay? So we now have identify the u, our u is 3 to the cotangent x. What is its du, guys? Derivative is 3 to the cotangent x times the derivative of cotangent, negative cosecant squared x. Am I right, guys? Or what else? The multiplier times, guys, ln 3, right? Then dx, okay? So times 2 times this. So this integral now, I can have it as what? Integral, because we are going to supply 3 here, and we know that's together with negative, and we know that 1 over sine squared is cosecant. So I will rewrite that into tangent of 3 cotangent x, and then I will be applying correction factor. No? What am I going to supply? I can rewrite this as 3. So negative 3 to the cotangent x. Then I will bring this sine 1 over sine squared up. Cosecant squared x. But originally wala pang negative, no? So we are going to supply that later. Then what else? Dx, no? Yan, dx. Okay? So what are we going to supply, guys? Anong isusupply natin? So supply natin negative because we want it to have negative there. Together with what, guys?
ln3 po.
ln3. So, but what are we going to do outside? We multiply outside by 1 over negative 1 over ln3. Okay? Negative, because negative ln3 what we introduced inside as a factor, no? So negative ln3. So that's it. It's now ready. So let's read. So negative 1 over ln3, negative 1 over ln3. I'm trying to make it nice one so that this is the file that I'm going to upload to you. What is the integral of tangent u du, guys? So again, this is what? This is u, guys. What is this? U. What about this, guys? What is this? Du, right? That's du. Okay? So integral of tangent u du. Or what's the answer? ln of secant, no? Pag negative ang ginamit nyo, negative, ln of cosine. So ln of secant of, what is my u? 3 to the cotangent of x, no? Then yan, absolute value of that, then plus c. Okay? Yan, that's it. Any question, children? Guys, pwede rin yung ln of, then over ln3, ha, then negative. On number 5, we have integral of, but it doesn't mean involving trigonometric always under here, ha? There are integrals involving trigonometric integrands, but you can apply general power formula. Okay? So let's have this. Secant x, then 5x minus tangent 3 tangent 5x quantity squared. What about this? Suggestion? What is the first thing to do here? Can we apply immediately integration by trigonometric formulas, guys? Or we need some algebra here? We need to what, guys? We need to expand first the integrand, right? Because if I take the whole thing as u, then n2, there is no differential that we can have inside, no? So let's expand. So we get secant squared 5x, then middle term 3 secant of 5x tangent of 5x, and then last term we have 9 tangent squared 5x. Okay, guys? Guys?
Okay po.
So, but in your trigo, so how is secant squared related to tangent squared? So we can express what? We can express secant squared in terms of tangent squared. We can express tangent squared in terms of secant squared. Which one are going to retain and which one are going to transform in other form? Secant squared is already available in the list of formulas, no? So, but no tangent squared. So this is the one that we're going to transform, okay? So getting secant squared 5x minus 3 secant squared secant of 5x tangent of 5x, and then plus, what is tangent squared? Secant squared minus 1 multiplied by 9. Secant squared 5x minus 1. Okay, guys? Then dx. Then after that, we apply integration term by term. But of course, you have to combine secant squared 5x first and 9 secant squared, getting 10 integral of, guys, and what? Integral of secant squared 5x, right? Then multiplied by dx minus 3 integral of secant of 5x tangent of 5x. I think I got a mistake in the expansion. No one has noticed. This is supposed to be 6. No? Times 2 yan eh. Am I right, guys?
Apo, sir.
Dapat ay buti napansin ko. It's hard to talk and at the same time changing screen because I'm changing screen trying to look at your names. Okay, twice the product. Okay now. So you have to check my work now because I'm not perfect. I also commit mistake, of course, and I admit that no one is perfect, except God perhaps. 9. We combined already 9 to secant, getting 10. Then minus 9 integral of dx, right? Okay now, guys? So, the first one, I have to split 10 into 2 times 5 and give it to dx, no? So, I will have just 2. Then, secant squared of squared 5x, and then I will be giving the 5 to dx. So that if I read this, integral of secant squared u du. Okay now? So that is equal to 2 tangent of 5x. Okay? So no need to balance outside because I just split 10 into 2 times 5. So and then give the 5 to the dx. Then minus, what about here? I'm going to put 5 inside, so balance outside by 1 over 5. So giving 6 over 5, guys, right? So secant of 5x tangent of 5x times 5 dx. So this gives us the u to the common u of secant and tangent. Minus, I can now solve this, no? 9x. Okay? So the plus sec, you can have it after performing all the integrals. 6 over 5. Then, what is the integral of secant u, tangent u du? So that is secant u. And then lastly, we have minus 9x. And then, of course, don't forget secant Trigonometric. Okay? So, plus c. Our third Miss Universe. Fourth. A question, guys. Let's have secant. Let's have cos secant squared. Secant squared of ln of, let's say, arc tangent of x, okay, times 4 here. Let me write again. So for ln of arctan of 3x dx all over 1 plus 9x squared multiplied by arctan of 3x. Okay, guys? Let's see. Any suggestion? Which is the appropriate to you here? Don't get disappointed if in the first trial you will not get the correct u. So remember, in integral, it's really a trial and error. Although, if you are really familiar with the formulas and you can foresee what will happen, then you can immediately identify the u here. Ln of arctangent 3x. What about the du? What is its derivative? Anong derivative nito muna? 1/4 times 4 over, because you have 4 there, over what? Over u, no? Over u. What is u? Arctan. Ang u ng ln is arctan. Arctan of 3x, but you have to multiply this by the derivative of arctan. Anong derivative ng arctan? Derivative ng 3x. So that is 3 over over what, guys? Actually, the derivative is already suggested there, no? Okay? So 3 over 1 plus 9x squared for the derivative of arctangent, no? Then dx. Okay? Let's rewrite this so that we'll have 12 over all over 1 plus 9x squared. When you're writing fraction, mag-practice kayo to write or to identify where you're going to write many things, no? So if you're going to write many things in the denominator, you start there, so that when you write the numerator, it is at the middle. You'll able to approximate that it is at the middle of the fractional bar. so that you have a nice fraction. So you parang it's like you're being trying to design no correctly or nicely, no? So if you're ME, you're going to design machine. So of course you want your design to be what? To be in place, no? In the proper way, form, no? Okay? Kung kayo ECE, you want your design like mga cellphone na not deform yung screen and other parts. And then after that, looking at the given, so almost everything there, no? Except what? Except 12, I think, no? So the given integral can be written, how, how can I write the integral? Integral of secant of, if you, secant squared, if you feel it is bulky, so you can write this as u, no? Secant u. Yan. What is the du? So this is supposed to be the du. dx, what? dx, then yan, dx over, yan. So let's copy everything. Yan. Okay. 1 plus 9x squared, everything in the denominator, arctan of 3x, no? Yan. So, what am I going to supply, guys? Anong isusupply ko sa numerator?
12 po.
12, sir.
No? So, I'm going to multiply by 12. So, multiply by 12, then balance outside by 1 over
1 over 12.
So, this is now read secant squared u du. So, this is now du. Secant squared u du. What's the answer, guys? So, it is equal to 1 over 12. Tangent, no? Tangent of u. But what is my u, guys? 4 ln of arctangent of 3x. Now, mathematics is part of your exam, board exam. Kaya be sure you know your math also, no? Aside from your major. Okay, guys? Any question? 7. Integral of, let's say I have hyperbolic cosecant squared x squared, so times x here, and then I want it to be cosecant yan, of hyperbolic cotangent x squared. Okay, then dx. Let me, because I don't have a copy of the problem, I'm just trying to make one. Wala akong, I don't know where the book is. I don't have the book with me. Let's see if this will work. What do you think? Cosecant. Okay, let's see. Any suggestion here, guys? Let's put this first in a proper form, no? So we're going to begin with cosecant, and its argument is hyperbolic cotangent x squared, and the derivative of hyperbolic cotangent is related to hyperbolic cosecant squared, and then x squared derivative is related to x. So I'm going to put these remaining quantities to be part of the dx, no? And then that's a potential du later, or perhaps part, okay? So x, then hyperbolic cosecant squared x squared dx. Okay? So my u here, I'll take it as cotangent, hyperbolic cotangent x squared. What's the du, guys? Du is negative derivative of x squared is 2x. So, derivative of hyperbolic cotangent is negative. Hyperbolic cosecant squared x. Then, squared, no? dx. Negative 2x hyperbolic cosecant squared x squared dx. Is that correct now, guys? Still remember derivative naman ng hyperbolic tangent? What's the derivative of hyperbolic tangent, guys? Anong derivative ng hyperbolic tangent? Tatandaan nyo. Related sa trigonometric yan eh. So, I'm going to put here negative 2 balanced by negative 1/2. Because I will be putting here negative 2. Negative 2. Yan. As part of the du, no? Okay? So let's see if that will fit there. Integral of cosecant of hyperbolic cotangent x squared, then times, I put negative 2 balanced by negative 1/2, and then copy. Okay, guys? So this is now read as u, and this is du. Yan, that's du. Okay? In negative 1/2 integral cosecant u du. Oh, what's the answer, guys? Negative 1/2. Negative 1/2 ln of cosecant. Di ba cosecant yan? So ln of what? Cosecant u, but may u is hyperbolic cotangent x squared, then minus hyperbolic cotangent u. Cotangent of hyperbolic cotangent u. Yan. Then plus c. If you use hyperbolic cosecant plus hyperbolic cotangent, you put negative outside, negative, so you will be having positive. So it means you have an alternative answer of 1/2 ln of hyperbolic cosecant, cosecant of, so absolute value of cosecant of hyperbolic cotangent x squared plus cotangent of hyperbolic cotangent of x squared plus c. Number 8, integral of 1 plus cosine of of 6 ln x over x multiplied to 1 minus cosine of 6 ln x, then dx. Okay? Any suggestion with that, guys? We apply first an identity here. You cannot solve this directly from any of the formulas listed. If you still remember identity for sine squared 1/2 theta, that is equal to 1 minus cosine theta all over 2, while cosine squared 1/2 theta, that is equal to 1 plus cosine theta all over 2. Still remember this, guys? In your pre-calculus, if you had this in senior high, kung naman kayo college, meron kayong bridging subjects about trigonometry. So, yan. Pag ang 1/2 theta ko, let's say theta. So, pag 1/2 theta, here is theta. Pag theta, 2 theta. Pag 6 dito, halimbawa, kung 6 dito, what is here? Guys, kung 6 dito, ang coefficient ng theta sa cosine, what is the coefficient of theta in sine squared or in cosine squared? Guys, you just take half, okay? Kung 4 ito, 2 rito. Kung theta, 1/2 theta. Okay, guys? Okay, guys. So, I can
Yes po,
rewrite
sir.
this as, yan, yung 1 plus cosine theta, magiging 6 ln, magiging times 2. So, 2, etong cosine ang gagamitin natin pag sum. Cosine squared of tama. Cosine squared, ano yung magiging angle? Kung 6 dito, 3 ln here, 3 ln x. Then times 2, 2 times cosine, so that is 1 plus cosine theta. Then over, what about 1 minus cosine? So ito yon. Kung 6 dito, this is 3 also, then times 2 the sine squared. 2 sine squared of what? Of 3 ln x. And then times what? Dx over x. Yung dx over x, potential differential yun ng ln. Okay? So I can have cancellation here. 2 is cancelled out. And what is the identity for sine squared over cosine squared, guys? That is cotangent squared of 3 ln x. But still, this is not in the formula. So I can have an identity for this again. What is the identity for cotangent squared, guys? That is cosecant squared 3 ln x minus 1. Because 1 plus cotangent squared is 1 is cosecant squared. Okay? Panggutom na sila. Hindi na nagsasagot. Dx over x. And this is equal to, so let's integrate term by term. Integral of cosecant squared of 3 ln x times dx over x. Yan. So I'm planning to put something here later. Minus integral of dx over x. Okay? And this is equal to, I'm going to put here 3, because if this is my u, what is du? 3 dx over x times 1/3. Is that okay, guys? Guys, Jordan Philip. Jordan Philip. So what's the answer? Negative 1/3. Why negative? Integral cosecant squared u du is negative cotangent of u. But my u is 3 ln x. Minus du over u, that is ln u. Okay? Plus c. A question. John Rodel, Jordan Philip, Sarmiento Gonzalez, Angelo, why is it that I did not put any more absolute value to ln x? Yung ln sa x ng ln. Why is it that absolute value is not necessary anymore? Guys, What do you think? Why do you think absolute value to x in the ln is not necessary anymore here in the second term? Integral of d over u. Because of what? Because of the presence of ln x. It is already implied that x is never 0 or negative. Okay? So no need for this. So in the beginning pa lang, from the original, it's already understood or implied that x takes positive values only, except, for instance, the value of x that will make the denominator 0. Okay? Guys?